Welcome everyone to another episode of It Depends with Eli and Sanjeev. And today, boy, do I have an interesting guest for you. He was the founder of ZenSource, which he later sold to Citrix and it became ZenServer. He was the founder of Bromium, which he later sold to HP. And today he is the founder of Swim.AI. It is my great pleasure to welcome Simon Crosby. Simon, great to have you on the show.
Eli, it's always a pleasure. Thank you.
Thank you for coming. So you've been busy. I've been looking at Swim.AI, but for our watchers and our listeners that maybe don't know what Swim.AI is, would you mind telling us a little bit about what the company is?
Sure. You know, it's all about data, right? Sanjeev knows this. Ultimately, applications process data. So step way back. We used to have relational data, right? Simple things like my bank account and so on. Then Google convinced us that it was all about big data, right? And so we went down that path. And it turned out to be not really that. Every modern SaaS app and every large piece of infrastructure is now instrumented. Every product talks back home and so on. And these are events, but they are not transactions. Okay. How do we build applications, huge distributed applications, that are always consistent, in sync with the real world, and deliver answers on time? That's what Swim does.
Very cool.
Events, I would say, Simon, you raise a very interesting point. Even transactions are now becoming events because in a transaction,
you're right. Yep, you're right.
Because in the past, the way transactions used to work were, I have a balance in my bank of $100 and I deposit $50. Go do an update. So that's a transaction. It has to be.
Yeah.
But today, it could be an event that says here, like it's at end of the file, append an event that says we are adding $50 to the account.
Yeah. So we're all about to die under eventual consistency, right?
Correct. Yeah.
So large organizations are about to be deluged, if they are not already being deluged, by massive amounts of event data. So let me give you just a simple example. A large customer of ours is a US mobile provider, and we track in real time 240 million devices. Okay, that's 5 petabytes of data per day. Okay, that's 2.5 exabytes per year, just to do relatively simple things for them, right? So they can always know where things are and how to provide better service to their customers. So large organizations at scale, hey, Uber is here too, right? Who hasn't been in the position of, having the Uber car right in front of them, but Uber is still showing you the cars being a few blocks
around the
away.
corner.
Right. So we're there. So we're about to die under events.
I see. So you're saying that we are not ready for the vast velocity volume of data that's about to get unleashed on us, like 5G, autonomous cars. We're not ready.
Yeah, exactly right. And so if you think about cloud computing, yay, it scales.
Yeah.
But really, clouds are just fronts for database companies, right? I mean, they just sell you different kinds of databases. Sure, they'll run your app, but ultimately, everything in the cloud depends on first storing the data and then analyzing it. And that just doesn't work. It doesn't work for the use case that is Uber. It certainly doesn't work for the use case, which is you and I are near each other right now, and so we should do something together, right? Or, here's one we do with trucks, which is like this truck has bad braking behavior, stop it from driving onto the freeway, right? So that kind of thing, which requires immediacy and a response in sync with the real world, yeah, brother luck.
So, but
So go ahead.
so Eli, after you.
Sorry, I think we're all going to have so many questions.
Yeah.
So, how does Swim
Yeah.
AI? How is it addressing this problem? Like, how are you address? So, you brought in an interesting keyword, the immediacy. So, the real time. So, how are you able to process this amount of data in real time to produce? Essentially, you're talking about a business outcome.
So first of all, every time you reach out to storage, a hard disk, you're talking about going 1,000,000 times slower than the CPU
Mhm.
memory. Okay, let me give you what 1,000,000 is. It's a speed comparison between a snail and an F-16.
Mm.
Okay, just to get that in perspective, right?
Yeah.
Okay, so this idea that, say with Lambda, AWS Lambda, you can have massively scalable event infrastructure which fronts, devices and things, and then you're going to write to a database. Oh my God, how pathetic is that? So fundamentally, things are stateful. So step one that Swim takes is to make an actor a stateful in-memory process for every single thing that is generating events. So you might call that a digital twin in your former Gartner IoT days, Sanjeev.
Yeah.
But these things statefully consume their own events. They're concurrent. So 240 million for my telco customer, each consuming its own events and statefully evolving in memory. Okay? Yeah, it's persistent, but persistence now is all about high availability.
Mhm.
These
Correct.
are massive distributed programs
Mhm.
which are all in memory where object actors talk to each other. Now, how do we solve? So, in the database world, that would have been a row, a stored program, a stored procedure for a row, right? So, when a thing updates itself, it's typically updating one or more columns in a row. Okay, cool. How do you solve problems like you and I are near each other, or these two processes are correlated in time or space? Hard. So what Swim does is Swim builds a graph
Hmm.
from data in memory of linked actors, and actors continuously evolve this graph based on their own solution to parametric problems. So problems of geospatial collocation or correlation or whatever, or even prediction. Okay, so these actors link to each other to form relationships, and the relationships also are actors, and they can currently execute. So whenever an actor changes its state, the relationship is immediately recomputed. So think of it as slightly differently. Whenever an actor changes its state, it streams its state change to another actor, which automatically recomputes the relationship and the answer. So massive distributed graphs, billions of actors concurrently executing in a distributed fashion, all in memory, overlaid on some number of instances somewhere. You don't really care about where. And the key thing is that the actors themselves find the relationships, and the relationships are continuously reevaluated based on evolving state. So programs are big distributed groups of actors which collaboratively solve the problem.
So, Simon, if I were to look at the taxonomy of database management systems or data stores,
Yeah.
We have relational, we have key value, columnar, document. Would
Yeah.
it be accurate to say that Swim is an in-memory distributed graph database?
Except that every vertex in the graph is a concurrent actor. So
Okay.
it is continuously and actively acquiring data, right? So if it's a leaf node,
Mhm.
it's a thing. So you could think of it as a digital twin, and in which case it's acquiring its own events and stably evolving. A good example would be a traffic intersection where we get squads of data and we eventually end up as red, green, or yellow, and whatever else, right? Um, and then if it's an interior vertex, it's continuously reevaluating predicates, complex predicates, based on changes in its inputs. These complex predicates, by the way, might be materialized views in, say, a redshift, right? Um, but normally views only get evaluated when you look at them, when you use them. Here they reevaluate themselves continuously so that they always have the answer. Does that make sense?
I see. So there's that dynamic property to it.
Yeah.
Yeah.
And so let me tell you some crazy things I found out. So this is simply Moore's law. This factor of a million is a big deal. So for this telco customer, they used to have 500 nodes in the AWS and tons of data, right? They're getting 5 petabytes per day. And now, courtesy of simply Moore's law, that is, this graph of actors is 100% in memory and running a million times faster. These 500 nodes are reduced to 50. 50. Okay. Now, instead of getting insights on a 10-hour time scale, they're down to 10 milliseconds.
Do you store this data or is it processed in real time and then discarded? Like, are you just focused on providing immediate real time insights and then moving on, or is it stored to do
So
something with it
I
later?
think in this whole data discussion, we've forgotten that what we really care about is state. We don't care about raw data. Google convinced us that we care about data, or maybe Snowflake did, right? But ultimately, can you afford to pay the storage cost for 5 petabytes a day? Nope, you cannot, even if you're buying hard disks, okay? What you care about is the state of the system. You care about the state of 240 million things, right? And where they are, and maybe you care about the last hour or whatever for all these things. And by the way, for let me be careful here. For each of these 240 million things, I care about its behavior in the sense that I might want to predict where it's going to be, but I can learn that on the fly. I don't have to keep all of the historical data, right? Okay, so when you want to know about things, you know about things in the future probabilistically, which is really just learning and prediction, right? Okay, but it's always very easy to keep in an hour or so of data for everything.
Sure.
So, do you want to keep the raw data? Yeah, no. Seriously, no. I
See,
mean,
this is what I love about Simon. There's always a different angle of looking at things. So I like it. I mean, I agree with you that at some point, the amount of data is just too difficult to store, even if there is value to be had and run analytics on it after the fact. And there's always something that you can do with the
yeah,
data after the fact.
right.
But if you're able
I fired a customer. I tell you, it's a very non-God thing to say. But this is a customer. So these guys operate 40 large compressors for gases, right? Each compressor gives them 70 data points per degree of rotation for each of 4 shafts. The shafts go at 2,500 RPM, 364 days a year.
Mhm.
And
Yeah,
these guys are building a MongoDB database to store all this useless data.
correct. Yeah.
Okay? And in spite of what we can do, which is, analyze what's going on and maybe predict a failure, these guys still want to save all the raw data because engineering said so. And the
Mhm.
last time I saw them, they were still buying hard disks. It's like, good luck, guys.
So what you're basically proposing is a complete mindset shift. So, the idea, because I mean, we grew up on this idea of you got to store the data, we got to, analyze the data. So this is a complete mindset shift. And I can see your point. I mean, we are going to continuously add more data, especially as we move into metaverses and everything else that we're going to talk
Right.
about in a second.
Right?
So,
Yeah, think about state, not data.
so Simon, the examples that you're giving, like how fast memory is compared to disk million times, that's not something new. I mean, we've been doing in-memory databases for a very, very long time.
Yes.
Kafka
But
has
yeah,
KSQL.
yes. But here's where those things fall down. Ultimately, what you care about is the insight, right? And by the way, real-time insights, which is real-time UIs in front of humans, yeah, whatever. Who cares? Okay, there are a million and one of those things out there, and humans are slow. Okay, what I care about is that the self-driving car does not enter the intersection when it shouldn't.
Mhm.
Okay, so I have to be in sync with the real world.
Mhm.
Okay, not putting up a real-time UI in front of you. Okay, so real-time. So the problem with databases is that we can update rows in real time. Lambda will allow us to, or whatever. We can update rows fast.
Mhm.
But the computation of the view, the analytic, which is, say, a prediction or, a computation based on the state of multiple rows, so a columnar operation, OLAP style, right?
Mhm.
Is driven by consumption. When I look at the thing,
Yeah.
compute the view. Okay. And that is massively problematic. What I want is to know the answer all the time. And the moment it changes to something like hit the brakes, I want to know. I want an automated response. Okay. Which means that as the world changes, you have to compute. And the moment it changes to something you care about, you have to respond. And so this is data-driven computing, not view-driven computing.
I see. So how is Swim different? Like, if I'll give another, so there are the complex event processing,
Yeah,
we don't even use anymore.
yeah.
But,
You're right.
yeah, but you got like Flink and Spark's structured streaming SQL. But then there are databases. The Aerospike comes to my mind. I don't know if you compete with them. Redis is an example. For
Yeah.
example, now in case of Redis is an all in-memory database.
Yes.
They have for durability and availability. They have disk storage, but that
Yes.
is if all else fails. Otherwise, you
Yeah.
go from primary cache to secondary cache to active geo distributed. So they're
Yeah.
already doing this. They got Bloom filters and all that. So my question is, how is Swim different?
So it's kind of what I said. I mean, those are all awesome databases. And indeed, in many of the use cases that we deal with, we integrate with those databases.
I see.
Our
Okay.
customers, so if you look at our mobile provider, they now have 240 million in memory things which are stable representations of everything that they own, right, or control.
Yeah.
And these are continuously informed by multiple streams of data. Some from Kafka, Pulsar, Redis, whatever. They have tons of different updating infrastructural pieces, all of which is fused in memory to an actor, which continuously and stably represents that thing. Okay. And then applications really are graphs that combine views of all of those things based on some need, right? So there is a security need or a proximity need or whatever. So let me give an example. The mobile carrier can now say how many devices are in every 200 square meter block of the US, and then they can sell those insights to property owners, right? Okay. So that need, which is an application, is just a graph, and the graph is built from the data.
Yeah.
So as things change, the graph changes.
Right. I think, I'm seeing that. To me is a unique thing. You're inferring the relationships in real time, building a dynamic graph.
And then the graph, so here's another really, really cool thing. The graph is overlaid on distributed compute instances, and those compute instances could be anywhere. What we do is we put every actor effectively on the web. Its streaming API is a URI, and actors migrate to the right compute instance automatically. So all the nonsense about, microservices and where they should run and distributed databases and how they run and DR and all that stuff, forget it. It's just big distributed graphs of in-memory continuously operating actors. Some managers where they run based on a fairly complex set of optimization criteria. They try and get close to where their data is. We try and ensure that subgraphs run on the same instance, and for availability and response time needs. And we also honor things like affinities. If a particular actor wants a GPU, say, we'll migrate it to an instance with a GPU.
I see.
So it can learn and predict, right?
Yeah.
And so what the runtime does is continuously operate this big distributed application, which in the case of this telco example is 1 billion or more actors, by distributing them over distributed runtime instances. Now, the total memory size is the total size of the database that you used to have, which by now is what, tens of terabytes? Who cares?
Yeah.
Okay, so it's all in memory and it's all running and active.
I see. Got it. Okay.
So really, this is the actor model applied to streaming data.
Simon, is there a particular industry that takes advantage more of Swim than others, or is this applicable across the board?
So Sanjeev and I, I'm sure, could compare notes and show each other the scars from IoT.
Yes.
It's a terrible place to be. What works for us is organizations where they have tons of things. The things, so they're at scale already. The things are already instrumented, and they want insights really fast. Okay, so carriers are awesome. Mobile operators in particular. 5G is great. IoT, oh my God, it's a disaster zone. So
something like an Amazon Fresh.
Oh yeah.
I mean, that could be applicable.
Retail, Yeah, all the kind of new economy things, right? Where you're trying to automate um, traditional processes on the fly, right? So you're trying to predict things or control things at massive scale.
Mhm.
So those are all great for us.
So if one of our viewers is interested in trying out Swim.AI, what do they do?
Go to swimos.org. It's all open source.
It's all open source. Oh, wow. Okay. So then where do they deploy? Is it like SaaS based or they
So
deploy?
here's the cool thing. So
Yeah,
Swim is polyglot. Um, the core is all being redone in Rust.
I see.
But what's at swimos.org right now is both the evolving Rust code base, but the core is currently in Java.
Mhm.
We typically deploy in containers on the Graal VM, but you could use the Java VM. And apps are Java, JavaScript for UIs, and Python and so on based.
I see. Interesting. I see this. It seems to be a very interesting trend. InfluxDB came to
Mm-hmm.
my mind because I think it was written in Golang, but I could be mistaken. But
Yes,
it's being written in. It has been rewritten in Rust.
yes. Look, Rust is totally awesome. I think people have correctly realized that Rust is really powerful for embedded work because of its security properties. But I think Rust's future as a distributed language, that
Mhm.
is, language for distributed applications, is potentially huge.
Yeah, I see. I see.
So, Simon, I want to take you in a different direction. You brought up security, and I recently did a video that I haven't published yet on, ransomware in particular, and the fact that, I think in 2021 there was over 620 million ransomware attacks.
Mm.
So, can we take something like Swim and apply it to cybersecurity? Again, there's a ton of data that's coming in. How would that be applicable there, or is it
Yeah,
strictly
well,
IoT?
notionally you could. That is, if you look at Splunk, say. I mean, the idea of Splunk is, hey, we'll collect all the data and write the app, right? And the problem is it's slow and somebody has to write the app. In the Swim world, essentially for every thing, you have an actor and the actor learns about its own behavior. And when its behavior is weird, it can say so. And you might have something which is continuously computing a view, which is related to, say, multiple things being slightly weird. And we're currently deployed in a security use case in an oil and gas provider
Mhm.
where essentially that's what we're doing. Now, ultimately, the hard thing about security is that you have to have a good model of what's
Sure.
normal and what's not, right? But the alternative way of looking at it, which is swim relevant, is that these actors learn from their own behavior, and when their own behavior is abnormal, they scream, right? And if multiple actors scream, then you might have an incident, and that's the current use.
Very interesting. Let me follow that up, I guess, with another use case for things that are either here or are coming. So, what is the application in your view with something like an augmented reality, especially with all these lenses becoming popular? And then
Yeah,
also with the metaverse, like if the metaverse ever becomes some kind of a digital reality of our way of
yeah.
life, how is it applicable there?
So I look if I stepped to if I found an avatar of Zuck at the digital water cooler, I'd quit, right? Okay, just so you know where I'm at. Um, but ultimately, the avatar is generated by a computer. And what would be really creepy would be if the avatar was out of time with Zuck's voice.
Mhm.
Okay? So increasingly, as we enter this world of kind of blurred computer versus real life time zones, by the way, I think Uber is part of this, we have to keep computer applications in sync with the real world. Okay. And anything where that decision, where it's critical that you stay in sync within single digit milliseconds, say, things like Swim will play a hugely important role. And ultimately, I think we have to get away from this predilection for databases. So there are, as Sanjeev pointed out, there are, a million and one ways to skin a cat. There will be other ways to solve the problem using in-memory databases, but ultimately, this idea that we can store and then analyze, just forget it. We just can't.
Yeah.
This category of application where interacting with the real world, automating responses, dealing with humans, whatever, that category of apps, which is increasingly important, will have to be dealt with in this way.
Correct.
By the way, I think the word, or at least the term real time, is terrible.
Yeah, it is. Yeah.
Whenever you use it, I did an informal Twitter survey, and here was the answer. I think the answer was real time means just faster than the last one, faster than the last app I had to use. Right.
That's
and
fair.
So, I think we need to be more precise about what we mean in terms of staying in sync. I'm struggling for words here. But ultimately, for increased automation, we're going to have to be in sync.
Yes. Yeah, I mean, the true real time is only in cases like life support system in a hospital, or a rocket.
But it matters. You're absolutely right. Or a nuclear power plant or something.
Nuclear power plant, yes.
But it really matters for Uber.
Yeah.
Uber and any app which integrates some notion of a digital reality with my reality, that notion of in-syncness has to apply.
Yeah.
And by the way, this notion of in-syncness needs to apply consistently, independent of the scale of the app.
Mm-hmm.
So for Uber, that applies everywhere across the entire planet, always.
Yeah.
Independent of partitioning, right? So this idea of a big database, forget it. Even if you said by country or whatever, in the US, we would have to survive partitioning. So the Bay Area would have to survive partitioning.
Mm-hmm.
In the swim world, that's a subgraph. It's just a subgraph of actors which will naturally migrate towards the data and always remain responsive.
Yeah, makes sense. Great.
Interesting. So, Sanjeev, as you can see, Simon is not opinionated at all.
No.
Yeah, absolutely.
Absolutely not.
Promised us to be irreverent on this podcast. What predictions would you make, Simon? What would be your big predictions for 2022 and beyond?
It's funny. I've been thinking whether we aren't at kind of reset. I think, look, the big thing, which is cloud, and people adopting cloud, has kind of dwarfed just about everything else. My view on the infrastructure startup space is, it's boring. It really is boring. So, hey, we do Kubernetes better than Amazon. That kind of startup, forget it.
Yeah.
So I think the startup world, in the context of providing better infrastructural abstractions than the big clouds, good luck. It's too late for that. And I really think that, there are a bunch of good SaaS companies. So for us, it's really about being an interesting provider of a solution to the application domain, but
Right.
not being a SaaS app ourselves.
I see. Okay.
Speaking of predictions, and since Sanjeev brought that up, there's a huge debate around Web 3.0. And I'd love your take on it. Like, are we going to ever see Web 3.0, a blockchain-based, internet and applications? What's your opinion on that?
So blockchains are useful. The current notion of there is nothing you could do with a blockchain that you can't just do with a big distributed database and some math, right? Okay, so that part is all BS. Blockchains are useful. That is the notion of being able to attach trustworthiness to things. Okay. Now, is the JPEG worthwhile? Yeah, whatever. That's BS.
So you're
Ultimately,
saying you haven't bought any NFTs yet?
Right. I'll sell you one.
We will convert this video recording into an NFT.
Yes,
Yeah.
indeed. Actually, I saw one cool thing the other day, which was NFTs of music.
Yeah, I saw that.
Yeah, it
Too.
was kind of fun. Anyway, but I think we've inverted the value problem. There are tons of things that I want to attest to being true, like, say, my COVID card, right? I don't carry it. The paper is a bit dog-eared by now. So what I want is digital proof that this thing is real, but it's valueless.
So things like identity could play then.
Yeah.
Identity
So,
could be a big player. Yeah, I agree.
proof of provenance is really important. In the digital world going forward, it's fundamental, okay? So companies which are doing, say, proof of provenance for bills of materials, right? For software, bills of materials and so on, right? There are a few companies out there. That's really important. But I think increasingly, this notion of trust and trust tied to a thing is important. By the way, just me signing a thing, who cares? That DocuSign, say, a bunch of pixels on top of a PDF, that is important. But if I tie it, say, to my root cert, yeah, okay. And if I'm an org and I tie my signatures to my organizational root cert, yeah, okay. I believe it. I believe your org signed the thing, right?
Yeah.
All right. So this notion of proof of provenance, yep, we have to go there.
Okay.
So I guess your answer is kind of. We're kind of going to use some elements, I guess, of Web 3.0.
And I'll sell you my COVID card.
Well, you guys heard it here first. I'm going to have the only NFT of Simon Crosby's vaccine card for COVID.
There you go. It's valuable. It will be.
So my last question to you is, what can you tell us? What's coming for Swim.AI? Anything interesting for 2022 and beyond? Anything that you can share with us at this point?
So, continued evolution of the platform. I'm really interested at the rate at which the market opportunity evolves. Look, Kafka and Pulsar and so on are all strong signals, and my God, they're huge in the cloud. Strong signals that this event-based architecture is fundamental.
Yep.
The patterns are not there in terms of allowing developers to easily consume events and build applications. And they're way too concerned with how to run the app, where it runs, how the microservices interact with the database, and so on. And so we blur, there's way too much ops in this whole dev business. And one of the reasons I love what Swim has done in the actor model is that we get to automate ops.
Yeah.
So the actor model, by the way, traditionally in the Erlang days, right? Erlang on the Nortel, on the Ericsson switches, just ran forever. And the cool thing is that the programs are really simple. They distribute naturally and they run forever. Okay? That is a little bit of dev and no ops. Okay. And so I think we can, if I look at cloud, DevOps is kind of like, shit, we forgot to automate this one really important thing, which is ops. And so now we have to do that. And the actor model has an opportunity to help there.
Yeah. That's great.
Well, the conversation with you is never boring. I'm sure Sanjeev and I have a million other questions, but we're restrained on time. We'd love to have you again on the show, maybe a little bit later in the year, to tell us, a little more about Swim and, kind of what else you guys are going to be doing there. But I want to take this opportunity to sincerely thank you for coming on the show. This was awesome, as I expected it to be. Sanjeev, any last words?
No, this is super exciting. In fact, there's so many interesting things I've taken from this episode that I plan to repurpose.
Thank you. It was a real privilege to talk to you guys. And, who gets 2 Gartner analysts for free?
Oh, that's awesome.
Yes.
Well, thank you so much. Thank you for watching, everyone. Thank you for listening wherever you get your podcast. If you loved this episode, as I know that you will, make sure you like and subscribe to the podcast, and we will see you all next time.
Thank you.
Thank you.